We have discussed previously the electric field by a bar, but in this case we're going to change point P. And well, point P is at a distance y, not at a distance x. And let's state this is a bar of length L. And in this situation, well, we can define, for instance, this distance as x squared plus y squared if we state that towards this direction is the x direction. And in this sense, well, we start from the electric field being k integral of dq over r squared times the unit vector. And well, the distance r squared is x squared plus y squared, which is the radial distance from any given point of the bar towards the point P. So we can change this as the electric field being k, and dq, well, we can change it by lambda dx, since this is a linear density. The radial distance is x squared plus y squared, and then we have the unit vector. And the unit vector, in this sense, we're only going to take components of y, since components x are going to cancel each other, and the resulting vector will be in y. For instance, well, in this case, this is going to be y, which is the component y, over the hypotenuse, which is, for instance, x squared plus y squared, and this is just because of the unit vector. We're taking into only component y of the vector, okay? So, rewriting this expression, well, we can, for instance, generate this as the integral of, well, k lambda we can take it out from the integral, and it's going to be, and also we can take out the integral y, since well, y is constant, and this is going to be an integral from minus L halves to L halves of dx over x squared plus y squared to the 3/2. Now, this integral is performed by trigonometric substitution, so I'm not going to focus in that. And you can do this practice of this trigonometric substitution, and with a little bit of algebra, the electric field of this bar is going to be equal to 2kq over y, being y the distance from the bar to the point P, times 1 over, and this is going to be, for instance, square root of L squared plus 4y squared. And well, this is, for instance, the electric field of a bar.